Okay, I hope the PPT is visible. Okay, so till previous lecture classes, all the classes, what we were studying about was first we began with an introduction to computer vision, then we went on to the different types of geometric primitives and transformations, and then we went on to image registration where you looked at some some techniques for 2D registration as well as 3D to 3D registration as well as 2D to 3D registration and so on, 3D to 2D registration and so on, right? Now, so that was one application, in computer vision where you make use of, registering different images. That is one application. Now, here another field which comes under computer vision is tracking, or you also call it as object tracking. Okay, tracking or object tracking. So this is a very important application when it comes to computer vision. What this means is you're basically tracking an object. Okay, so that means let's say you're given some video sequence. Okay, you have a set of video sequence just trying to depict a video sequence here, and in if you look at each of the frames of these video sequence, let's say you have an object, okay, which is kind of moving. So let's say you have an object here and it slightly moves a little bit more upwards here. In the next frame it keeps moving up and so on. Okay, so let's say this is the kind of path it is following and the object is moving, okay, while the background is staying more or less stationary or uniform. So here in object tracking, what that means is, right, once an object is detected in the first frame, right, what you're doing is you're trying to find out what is the motion of the object or how the object is moving within each of the frames. So that is a general or a broad idea of what is object tracking. Okay, so I'll just say once again, object tracking means that you're tracking the motion of a particular object, okay, and given a particular video sequence, right? So in the first video frame, the object, let's say it has been detected using some technique, some computer vision technique has been used, and the object has been already identified in the first frame. So once you have an object which is already identified in the first frame, then what you do is next, from there starts the tracking algorithm. So what that does is, what you're doing is you're trying to track the movement of the object, right, as the video is progressing. Okay, so what that basically means is you're trying to find the path, this particular path in which the object is moving. Okay, and another name for saying that you're trying to find the path, you can also call it as trajectory, trying to find the trajectory of the particular object, moving object. Okay, so when it comes to object tracking, what you're giving as input is basically a video sequence, okay, and then as output what you're getting is an information on how the object has been, or what is the movement of the object, or what is the path in which the object has been moving. And this particular information on how the what is the movement of the object, or how it is moving, or the other aspects of it, like how fast it is moving, how slow it's moving, etc., all these would be useful for other applications. This would be further used for some applications where object tracking could be useful. So we will be having a look at some of these applications also, and then we look at detailed algorithms which deals with object tracking. Okay, so now here it's just an introduction to trying to understand what is exactly this object tracking. Now, as I said, here the input is a video. Just give me a minute. Okay, yeah, we'll continue. So as I said earlier, the input that you're giving is basically a video, right? So when you say video, what that basically means is, okay, you're giving kind of a video can be thought of as a set of different frames, okay, or you can say, you can call it, or you can assume it to be a set of different images. Okay, so you can treat this first frame as an image, the second frame as another image, and so on. So you can say that it is a set of images, okay, which are kind of stacked together in the time axis. Let's say this is a time axis. Okay, so here at a particular time, let's say if this is the initial frame, you have it, or it starts at a time 0 or so, if you're considering that, then the next frame may be at maybe 0.2 seconds, or here it may be at 0.4 seconds or so on. Okay, so just to give you an example, okay, you might you will be having, or video can be thought of as having a set of images which are kind of stacked together or aligned together. Aligned is not the word, which is stacked together along the time axis or the temporal axis. Okay, so as I said earlier, once the object has been detected in the first frame, what you're doing is you're basically then trying to track that object in the subsequent frames and see how exactly it is moving along as the video is progressing. Okay. So as I said earlier, each of these images, okay, it can be called as frames. You call it as the video frames. Okay, and okay, so we'll move ahead now. Fine. So when you're saying tracking, okay, what you're basically trying to do is trying to find the motion of an object, or in other words, you're trying to find the path of the movement of the particular object given a sequence of images. In the sense, okay, you have a video which is basically a sequence of images, and given that, you're trying to find the motion of the object, right? Now, from this, okay, whatever you're trying to derive, basically what you're trying to do is you're trying to find out some measurements, okay, and these measurements will help us in trying to find the trajectory. So these measurements can be, for example, it can be the position, okay, of the object, or it can be the velocity, okay, or it can be acceleration, also, etc. So there are different kinds of measurements, which could be taken. So you measure all this, and what you're doing is each of these measurements, they are done, okay, in each of the like for example, if you have this video sequence here, okay, and you have these different frames over here, right? So for each of the frames, you try to find out these measurements, okay, like for example, let's say the measurement that I'm doing is finding the position of the object. So once the object has been detected, right, in the next frame, again you find the new, what is the new position, the location of the new position of the object. Again, in the next frame, you again try to find the same measurement, and so on. Okay, so there would be a set of measurements that you would be determining from each of the image frames. Okay, and from those measurements which you are taking, you are trying to deduce, or you're trying to kind of find out what is the movement of the object, or what is the exact trajectory of the object. Okay, now each of these measurements that we are doing, okay, as I said, what we are doing is we are taking a frame by frame basis and doing each of the measurements, and finally it is giving us a path, right? So what we can say is that we are basically we are trying to infer the state of the object. Okay, we are trying to infer the state of the object in the sense, like for example, if it is a position, etc. Okay, so we are trying to find the state of the object, and we are doing some measurements to find out how exactly is the trajectory. Okay, so we infer the state of the world in the sense the object that you're taking, okay, from the measurements that we take from frame to frame. Okay, and we also take into consider the model dynamics. Okay, so these three terms, state, measurement, and dynamics, how exactly it is defined, we'll see in the next slide. Okay, now let us go to some applications of tracking. Okay, there are some very interesting applications for tracking. One of such application is basically motion capture. So what motion capture means is that Like, for example, let's say you have a movie, okay, it's an animated movie, and you have an animated character in that movie, okay, and you want to, you want to create some kind of a motion. Like, for example, let's say there are some stunt scenes, or there are some, motion which you want to incorporate on this animated character. So one thing which is done, with the help of this object tracking concept, okay, what is done is there would be a performer, okay, who would do the particular actions. Like, for example, with some stunt actions, that person would be doing the stunt actions, and that movement would be captured with the help of sensors which are attached throughout his body, okay, and using these sensors the movement is captured, and then that movement is then kind of rendered, or it is reproduced back to the particular animated character, okay. So what happens is, as you see in this figure, since all these sensors, they all kind of take measurements of different aspects, like, for example, the position, the direction in which the movement happens, or the velocity, etc. So depending upon all these measurements which are taken, okay, from each part, so for each part of the body, okay, that motion or the trajectory would be different, right? So for each part of the body, wherever the sensors are attached, that trajectory or the path of the movement along time, right, along as the time passes by, that is captured, and then that same movement is being rendered to the animated character. So this is one important application of object tracking, okay, where it is trying to capture the motion and then render it back to the animated character which is there in the movie, okay. So that is one example or one application. Now, another application which you can, which is useful, or which makes use of the object tracking, is basically recognition from motion. Okay. Now, what that means is there is some movement, right? And what object tracking does is it will try to find out the path or the movement of the object, right? Now from there you're trying to recognize what is the movement. Okay, so that is what you mean by recognition from motion application. So for example, as an example, you have three figures which are given here, right? So in this figure, what happens is, now let's take for example this particular figure, right? So what this means is, now this outline that you see is basically the person walking. Okay, it is only one, only the side view is visible to us. Anyway, it is exactly the same as this, the person who was walking, but in the first frame. Okay, so in the second frame, again, the position and everything has been calculated, and you get this, right? In the third frame again. So this, what you see over here, is basically all the measurements which have been taken from each of the image frames, and they are stacked together. Okay, so what happens is, now if you look at this, it kind of gives you an appearance on how the person has been walking, or what is the exact path. It's not just the path of where he has been walking, but also the whole gesture, that is the whole movement, the gait, the movement of the hands, etc. So the whole body movement is being captured over here, right? So the hand movement, the leg movement, etc. Now, once you know this trajectory, once you know how the movement is taking place, you can recognize what is the activity which is happening over there. Okay, like for example, if you look at these three figures over here, these are three different activities. Okay, this middle one which you see here, it's just walking. But if you look at the last one over here, it is basically running, or you can also say it is jogging or running basically. And here, if you see, the person has actually lifted the arms, right? And it is kind of going this way. So it is, it looks like that it is some kind of an exercise which is being done, right? It's anyway, it's neither now walking nor running or jogging, right? Because you have these hand movements which are very prominent, right? So Now what you can see is the trajectory of all of these are different. Okay, if you're trying to see for all the images stacked together, it is quite different. So it is possible, or what can be done is by looking at these movement or this motion information which has been captured over a period of time, you can easily try to recognize, or you can train machines to understand and recognize what exactly is the type of action which is happening. Okay, so for example, you can say that if you have this kind of pattern in which the trajectory or the motion is, then it can be classified as, or it can be recognized as walking. Okay, otherwise if it is this one, it can be recognized as running and so on. So that is basically the application of recognition from motion, where the object tracking will help to find out what is the motion of the object, right? And by looking at that particular trajectory over a period of time, we will be able to train machines to recognize what is the type of activity which is happening over there. Okay. So this is a very interesting application of the what recognition from motion, or basically the object tracking. Okay, now how that can one application where it can be used is just one application. There are many applications, but one of them which can be used is, so let's say there is some kind of a motion or a activity which is happening, and then you have recognized what is the activity or what is exactly what is happening over there. Okay, and one application which comes from this recognition from motion is where you can convert the actions into text. Okay, a kind of algorithm where it is able to recognize what is the motion and then convert it in the form of a text. Okay, or in the form of, let's say, a sentence. Like for example, okay, you can say after looking at this, okay, after recognizing that this is basically a walking activity, then the probably the text in which it is converted may be, okay, just walking, or it could be a sentence form saying that so and so person, or he is walking, or so and so person is walking, and so on. So recognition from motion means trying to recognize what is the type of physical activity which is happening by basically looking at the trajectory which has been determined by the object tracking techniques. Okay. Now, another application of object, tracking is surveillance. So, in surveillance means, basically for security purposes. Like, for example, you're trying to monitor what is the activity of a person, or maybe of a group of people. Like, for example, if it's a crowded area, or maybe sometimes it would be for a particular person as such, right? And by trying to find out what is the motion or the movement of the person. Okay, if you're also able to identify what is the type of movement, that is recognizing the movement also. Okay, what happens is, if there is any kind of abnormal physical activity or any kind of suspicious activities, or any yeah, basically suspicious activities, that can be that can be highlighted, right? Because the CCTV or whatever the surveillance cameras which are being used, right, they are able to monitor, or from which, from those surveillance cameras you get videos, right? And from these videos you will be able to keep on monitoring what is the activity of, maybe it's just one person, or maybe it could be several people, right? You will be able to monitor the activity and track the movement of the people or that particular person. And if you are if it is being able to recognize what is a physical activity, again it can be helpful, because if it is something which is not normal, if it's not a normal activity, if it's some kind of a suspicious activity, then that can be immediately alerted or reported or so on. Okay, so like that, for surveillance also you find that object tracking plays a very important role. Okay, Then regarding tracking, another application which you see is tracking the missiles using radar signals which are obtained. So if you look at tracking algorithms, okay, one of the earliest algorithms which has been using the tracking algorithms has been using it for the finding the trajectory of the missiles using a radar or infrared signals. Okay, and as you know, you already know why it's important to actually monitor the trajectory of the missile, right? So there has been a lot of work which has been done in tracking of missiles, etc., for defense or such purposes. Okay. Now what we'll do is we'll just go and learn some of the basic terms, okay, which is associated with tracking. So in the previous one of the slides, we had been familiarizing with the term state. We saw the term state, we saw the term measurements, we also saw the term dynamics. Now let us try to understand what exactly all these means, okay. So again, when you're saying tracking, what you're doing is you're trying to find out what is the movement or the motion of an object, right, given a video. Or basically video can be thought of as a sequence of images. So you can also say, given that you know what are the image frames, or you have the image frames, and then you can find out the motion or the movement of the object, right. Now so what we say is that each of the moving object, okay, is having a state. Okay, it has a particular state at each frame. So in each frame when it goes, it is at some particular state. Okay, but that state, maybe it is something that can be observed easily or directly. Maybe it is not something which can be obtained or seen directly or so. Okay, so anyway, whether it is observed directly or not, always when you're looking at an object, right, which is moving in a particular sequence, you can say that the object is having a particular state, right. So when I say state, it is nothing but all the information which is present in the particular object, all the information with regard to the movement of the object. Okay, so that is what you call as state. Now, when I say state, okay, the state could be just position of the object, or sometimes it could be both position as well as velocity. Okay, sometimes it could be position, velocity, and acceleration, and sometimes it could be position and appearance, and using many other quantities together. Okay, so that could differ. What is the exact state that you're looking for? Okay, and the type of measurement that you're doing would be differing. Okay, so for now, remember that when you're saying state, what it means is any quantity which helps in determining what is the motion, right? And some examples would be using position along with velocity and acceleration and so on. Okay. So what this means is it is basically these which would be measured in the first frame, okay, and then subsequently in the next frames also, in order to find out how exactly it is moving, right? That is, let's say in the first frame over here, right, you have a particular object and you have found out what is the value of the position and velocity, or let's say only the position of the object, you have found it out, right? And then in the second frame, what you do is again you find out for that same quantity, and like that you keep on going. So that particular quantity which is of interest to us, okay, may be different. Like it may be along with position and velocity, sometimes it may be along with velocity and acceleration and so on. Okay, but state can mean any of these combinations. Now another term which you need to be familiar with is measurements. So what measurements means is, now as I said, the state may not be observed directly. State may not be something which can be measured directly, right? So in that case, you can you can go with new measurements, Okay, new measurements in the sense we can take measurements of those quantities which can be quantified. Okay, and also those quantities not just being quantified, but it can also be computed in every frame. Okay, or something which is changing with every frame. Okay, so if you can what can be done is, since the state sometimes may not be able to directly measure it. Okay, you can go with new measurements of some quantities which are being changed in that particular image, right? And that changes would be with or should be with respect to the state, okay, of that particular object, as well as the each frame, how it keeps on changing, right? So in each frame over here, right, when the state of an object is keeping on changing, there would be some quantity which keeps on changing, as I said. Okay, and that quantity is measurable. Okay, and that is also called as, that kind of the measurements that we are taking, that is also called as observations. Okay, so when I say observations, what that mean is, what are the quantities that keep changing over each of the video frame. Okay, it should also ensure that that particular changing, the quantity which is changing, should contribute to or should help with finding out what is the trajectory of the object, right? So that measurements is what you call as observations. Yeah, here it is written. Okay, so these measurements that you take, these are also called as observations. So two terms which we have familiarized right now is the term state of an object. The second term being observation. Okay, observations, where you try to find out what is the changing quantities in different frames. Now, as I said, as an example, when you say state of a particular object, okay, it might be position of the object. Okay. Now, when I'm observing something, the observable which I'm using, okay, or the observations that I'm doing, okay, now that could be different or that could be the same also. So, like for example, if you're looking at the position of an object as a state of the object, again, it may be also possible to look at the or find out the position also of that particular object, right? So that means we are observing the position of the object. So here the attributes which are linked or associated with the state and the observations is the same. Okay, so in this case it is the same. It need not always be the same. It could be something which is different also, what we are observing. But always what we say is that observations, it would be some functions of state. It has to be some functions of state, because why we are using observations, or why we are measuring some other quantifiable measurements, is the basic idea is because you want to find out the state of the object over a period of time, right? So in order to find out what is the state of the object over a period of time, it has to be the observations or the measurements you are taking should be some functions of the state. Okay, so only if it is some functions of the state would it be actually able to measure or try to, we can determine what is the state of the object. Okay, now yes, now another very important term, okay, which you need to remember is basically dynamics. Okay, now let's see what dynamics mean. So dynamics, object dynamics means how the state of a particular object, okay, changes with each frame or changes over time is what you call as dynamics. Okay, what are the changes which happens in the object state, okay, while it keeps changing over time, okay, is what you call as dynamics. So how that helps is that if you know what is the object dynamics, you can tell, is the object fast, is the object going slow, or is the object going at a constant speed, which is kind of maybe tolerable to us, or depending on the applications that would be different. Okay, but when you are saying object dynamics, what that means is you're trying to figure out how the state of an object keeps changing over time. Okay, so that is object dynamics. Okay. Fine. Now let's look at look at some more details of the tracking algorithms, or basically the idea of tracking. Now the observations or the measurements that you're making, okay, they are usually hidden in a great deal of irrelevant information. Now what that means is, like for example, if you have a particular, let's say this is a first image frame, or the video frame, the first image which we are considering, okay. Now the object which we are trying to track may be an object which is kind of, not that big, okay. It might be something small which looks, which may be only this much. And what you're trying to do is, for each of the remaining slides that you have, or not slides, or each of the remaining images that you are having, right, you're trying to find out how this is changing over all these images, right. So maybe this position was here, maybe here it's a little higher, maybe here it's a little lower, or so on. So here what happens is, when the position is changing, what we are doing is we are trying to find out how exactly this object is moving, right. Now the actual area of interest or region of interest for us is only this much. But when you look at the image, you see that, see, the image is this much, right? So if you look at how much area or how much of the region the object is actually occupying, okay, that is actually very less. Okay, so that is what you mean by, if you're trying to make the measurements, okay, there is a lot more in the image which does not contribute to the measurements or the observations regarding the state of the object that we are looking for, right. So it is usually hidden in a great deal of irrelevant information, okay. And the same examples have been given over here also, okay. So what you can do is, basically you can try to find out, you can use a detector to try to find out what is the region, having or containing the object of interest to us, okay. And based on this, you can correlate with all the other slides. So that not slides, all the other images or image frames, video frames that you have, right. So that we'll see later how it's done. Okay. Now, if you look at object tracking techniques, okay, there are basically two types of techniques. You have tracking by detection, okay, and tracking by matching. These are the main two, types of tracking methods that you have, okay. So when you say tracking by detection, right, what that means is you're trying to, so let's say you have a particular frame here, right, and you have another frame here and another frame here, okay, and this is the time axis, okay, which is going. So this is basically my video sequence that I have, right. So in tracking by detection, what is done is you try to detect which is the object, okay, right, in the first frame itself. And in order to ensure that you are detecting the object with a very good accuracy, and it is you're highly confident that that exactly is the object that you're looking for, right. So in order to do that, you need to make sure that you're using a strong model of the object, or a strong, like for example, if it's the face of a person, it should be a strong face detector. Or if it is some kind of maybe you're trying to detect a ball, or it might be some other object, right. So depending upon what is the object, that particular kind of an object detector has to be used, okay. So in this approach, which is tracking by detection, it makes use of an object detector, a strong object detector, in the sense, okay, an object detector where you have a high probability, or with a high accuracy, with a high confidence level, you can say that yes, whatever this has detected is the actual region of interest for me, and or the object for me, and this is the object which I will be tracking throughout, right. So first step, as I said, what you do is you have an object detector, and then using that object detector, you try to find out what is the object right in the first frame, right. Now, so once that is detected, right? So what happens is now in each of the images, you can do this kind of an object detection independently. Okay, so here you have this. In the next image, wherever you have this object, okay, to find that out, again you use object detection technique. Okay, so like that you can individually do for all the images. Okay, and then you can once this is determined for all the images, you can simply kind of interpolate or try to stack them together to find out what exactly is the path in which it is going. Okay, so that kind of an approach where you make use of the object detector is what you call as tracking by detection. And another second method, okay, this is just a broad area. Okay, you'll have different algorithms that come under that. So the second type of tracking objects is what you call as tracking by matching. Okay, so in this technique, tracking by matching, what is done is, okay, so let's say you have in this first frame, let's say you have an initial guess of, okay, this might be the region proposal, okay, or this might be the region of interest for us, right? So once you have that, once you have this initial guess, okay, what you do is in the next frame, you try to look at the neighborhood and see whether it is matching with that of the first frame, with what has been detected in the first frame. Okay, so it's like you're trying to what is it, you're trying to kind of propagate from here. So now that you have this as the initial guess, instead of going for the next image and treating the whole image as a new image and doing the whole trying to find out the whole state or take the whole measurements, what you do is, once you know what is the region of interest for us, once you have this initial guess in the first frame, then in the subsequent frames, okay, you can kind of just use the same type of information to have a region of high probability from where again you can find it out. Okay, so how exactly that is done? It is by looking at the neighborhood. Okay, so the neighborhood which is matching with that of the initial guess in the first frame would be considered in the second frame. Again in the third frame, again the similarity of the neighborhood is taken in order to find out. So in that way, it is kind of propagating from one slide to the other in the case of tracking by matching. Okay, let me look what is the time. Okay. Okay, so first, now we'll see in detail about tracking by detection and tracking by matching, right? So first we'll see what is tracking by detection, right? So as we said earlier, there would be only one. So what is the basic assumption that you make is that only one object may be available in each of the video frame, or when you're looking at each of the images, only one object of interest, whose trajectory has to be recorded or measured is or will be present. Okay, and the state that we are trying to track may be the position, right? And what we do is we try to find out a particular detector, okay, for that particular object, detect, like for example, if it is human faces, then it may be a face detector or so on. Okay, so you'll be using dedicated or reliable detectors for detecting the presence of this object, right? And as I said earlier, so once you have that, you can easily do or combine all that information together and you can track. Okay, so let's say for example you have a particular sequence over here. Okay, so let's say you have a red ball on a green background. Okay, so if this is the image and you have a red ball over a green background, okay, the kind of detector that would be looking at maybe, okay, it can be any kind of detector. Okay, just as an example, the detector that we may be using maybe something where it looks for red pixels. Okay, so it might be something which is as simple as that. So if you have a particular image sequence where the background is fairly uniform and with a uniform color too, and the object is having a different color and appearance as compared to the background. Okay, so if you have such kind of a video sequence, then the task becomes very simple, where in the detector all it has to look for is some red pixels, because that in the background it's all green pixels, right? So that could be one of the very simplest way by which you can describe how the detector works. But it is not as simple as that. If you see, when you're looking at, let's say, if you want to find out the motion of an aeroplane, if you want to find out the motion of a ball when some match was going on, okay, or there could be many such applications. So all these applications, what you see is that the background is never uniform. The background may not be having only one hue, there would be different colors for the background. Okay, so in such cases, a detector as simple as that may not be sufficient. Okay, but just to discuss in this context, you can think of a detector for this particular special case to be as simple as just looking for the red pixels. And if you have the red pixel areas, then you can say that those are the areas where you have the object, okay, which is being tracked. Okay. Now, yeah, so in most cases, we can't assume only object or a reliable detector. Okay, now in some cases, there may be a chance where the object enters or leaves the frame. So what that means is, like, for example, if you have a video sequence, yeah, these are different images, there may be a chance that the object keeps on like, for example, sorry, not this, let's say you have an object, it is there here, then in the next frame it went here, then in the next frame it went here, and probably it went out of the frame, okay, in the fourth one, and then maybe after a few frames it might have started coming back again, like, for example, if it's descending, right? So there are chances where you may not have the object visible throughout the whole video frame. Okay, that is, for a few frames in between, the person may not be visible or the object may not be visible. Okay, in such a case, for a good object tracker, even if it loses that that object information for a few slides, when the object comes back, it should still be able to retrieve that and still recognize that as the object which is being tracked, and the remaining tracking should continue. Okay, so in such cases, what is done is, first you kind of from the first frame, let's say till this frame you had the object. Okay, so you can kind of track what is the movement or the trajectory over here. Right now the object has left, so it's no longer in the frame, but when it comes back, you can start it off as a new trajectory, and then you can try to continue with that. And there are other techniques also where you can kind of combine all these trajectories together to get a smooth path too. Okay, so here what you have to remember is that not always would there be an object in the image frame that we are considering. There are chances that the object may enter or leave the frame also. Okay, so so every object that we are basically considering over here, okay, it would be having a particular track. Okay, and that particular track will help us identify how exactly the object is moving in the video, right? So as I said earlier, what is done is the trajectory of the object is first detected with only those frames in which the object is clearly visible to us, and then after that a few images where the object is not visible, right? So here in these cases the object has moved out of the video sequence, and so the trajectory cannot be continued, right? But when it comes back, the detector should actually be able to detect that it is, yes, the same object which has come back, and then again the calculation of the trajectory with the subsequent image frames or video frames is then done. Okay, so this is about the basics of object tracking. We'll continue with the and the details. That is, we'll continue with the tracking by matching and more details about object tracking later. I think we can stop with the today's class. Do you have any doubts? Okay, now just 1 minute.